Introduction to Advanced Techniques. We all know that statistics is a mathematical science pertaining to the collection, analysis, interpretation or explanation and presentation of the data. In this lesson, we will describe factor analysis, explain cluster analysis, describe conjoint analysis, and explain multidimensional scaling. After going through this presentation, you should be able to describe factor analysis, explain cluster analysis, describe discriminant analysis, describe conjoint analysis, explain multidimensional scaling. FA and PCA, principal components analysis, are methods of data reduction. In factor analysis, take many variables and explain them with a few factors or components. Correlated variables are grouped together and separated from other variables with low or no correlation. Patterns of correlations are identified and either used as descriptive (PCA) or as indicative of underlying theory (FA). The general steps in factor analysis are: Step 1. Selecting and measuring a set of variables in a given domain. Step 2. Data screening in order to prepare the correlation matrix. Step 3. Factor extraction. Step 4. Factor rotation to increase interpretability. Step 5. Interpretation. Further steps: validation and reliability of the measures. A good factor makes sense. It will be easy to interpret. It has simple structure and lacks complex loadings. Cluster analysis means finding similarities between data according to the characteristics found in the data and grouping similar data objects into clusters. The quality of a clustering result depends on both the similarity measure used by the method and its implementation. The quality of a clustering method is also measured by its ability to discover some or all of the hidden patterns. Cluster analysis groups objects based on their similarity and have wide applications. Measure of similarity can be computed for various types of data. Clustering algorithms can be categorized into partitioning methods, hierarchical methods, density-based methods, grid-based methods, and model-based methods. In this analysis, two or more groups are compared. In the final analysis, we need to find out whether the groups differ one from another. Example, where discriminant analysis is used: those who buy our brand and those who buy competitors' brand. Good salesman, poor salesman, medium salesman. Those who go to food world to buy and those who buy from a kirana shop. Heavy user, medium user, and light user of the product. Discriminant analysis will highlight the difference in activities performed by each group members to get the prize. Conjoint analysis is concerned with the measurement of the joint effect of two or more attributes that are important from the customer's point of view. Conjoint analysis is a multivariate technique that captures the exact levels of utility that an individual customer places on various attributes of the product offering. Conjoint analysis enables a direct comparison. Conjoint analysis is extremely versatile and the range of applications includes virtually in any industry. MDS attempts to identify abstract variables which have generated the inter-object similarity measures, reduce the dimension of the data in a nonlinear fashion, and reproduce nonlinear higher dimensional structures on a lower dimensional display. In metric MDS, distances between data items are given. A configuration of points which gives rise to those distances is sought, can be used for nonlinear projection, and objective function which is minimized. In non-metric MDS, only the rank order of the distance is important. A monotonically increasing function that acts on the original distances is introduced. The rank order can be better preserved and normalized objective function En equals to 1 divided by sigma kl d to the power t kl square multiplied by sigma kl bracket f into d into kl minus d to the power t into kl square for given projection is always chosen to minimize. Now let's see how much you have learned till now. State whether the following statements are true or false. Discriminant analysis is a technique used for classifying objects into groups. False. In cluster analysis, two or more groups are compared. In the final analysis, we need to find out whether the groups differ one from another. False. Conjoint analysis is concerned with the measurement of the joint effect of two or more attributes that are important from the customer's point of view. True. Before we end, let us briefly revise what we have studied till so far. Factor analysis is used to reduce large number of various factors into fewer variables. Cluster analysis is used to segment the market or to identify the target group. Cluster analysis is a technique used for classifying objects into groups. In discriminant analysis, two or more groups are compared. In the final analysis, we need to find out whether the groups differ one from another. MDS has a set of multivariate statistical methods for estimating the parameters in and assessing the fit of various spatial distance models for proximity data. The output of MDS looks very similar to that of factor analysis, and the determination of the optimal number of dimensions is handled in much the same way.